Okay, folks. So this is going to be the last of the video notes for this course. So hopefully I cover the important details on the reading for this week. But before we do that, let's kind of review some differences between um, the modules and programs and subprograms and functions that we discussed last week. So before up to the chapter 7 of last week, we talked about modules. So modules were effectively the same, uh, the the code within the same program. So it's all one program. So let me see if I can find something real quick, and we'll take a look at that. Okay, so this was an example from way back in chapter 2. So all of this code is effectively one program, which means that these variables that are declared up here in the main module are also going to be accessible down here in the modules below. Um, so um, so as you declare these variables, again, this is all part of one program. Now, in the information that we covered in chapter 7, this area right here is no longer called a module, it's called a program. This is the main program, which our header doesn't indicate that, but we do indicate the in the program. So, and then down beneath we have sub programs that are effectively their own programs that do not see these variables up here. They have to be passed by a specific method, either by value or by reference. So so it's important that you understand that. It's important that you understand that as you are composing your final project, because that's going to be a very important factor in that grading. So let's take a look at functions real quick. If you have Windows 7, you well, any version of Windows since Windows 7 has PowerShell. So if you click on your start circle, and you can type in ISE, and you will see Windows PowerShell. Now I typically always open that as administrator. And now if you have Windows 7, you probably have PowerShell 2.0. Windows 8.0, I believe, has PowerShell 3, and then 8.1 has PowerShell 4. So PowerShell 3 is what you want. That requires a .NET framework. 4.0 PowerShell 4 requires .NET framework 4.5. So when you open your PowerShell, if you do a command git host, it'll show you what version that is. Again, I have version 4. Okay, back to the functions. Let's take a look at this real quick. Now these are different functions that we use at work, um, and if you look at these are all just a collection of functions. And some of these are very elaborate, and these do some pretty cool things. And you'll see that a lot of these access SQL databases or go into the Active Directory structure and gain information. So let's take a look at some of these. For instance, this function task sequence. If we just type that in the command line, it says, hey, I don't know what that is. But if I run this code that contains all those functions, it gives me an error and says, hey, you can't do that. Oh, hang on just a second. Let me fix that real. Okay, so you'll see that I just ran a command that is get execution policy, and it is restricted. So now one cool thing about PowerShell is as you type these commands, it says, hey, this is what you want to do, and does a auto completion for you. So let's set the execution policy to unrestricted. Now you don't want to do that for but if you're doing that at work, that's really bad because I mean that just opens it up to everything. So let me see if I can fix that. Of course, it might help if I type my commands properly. So let's get I tell you what, let's do a help on that real quick, and I'll show you how that works. Execution policy, and it'll show you the available commands. Now, this is missing some help information. You can just do a update help to get that information updated. So we'll do set execution policy and set that to unrestricted. Are you sure you want to do that? Yeah, sure. Okay, so let's run the script again. Run once. Okay, so all of these functions should be loaded in this shell. So let's do the task sequence one more time, see if I can find it. Task sequence. So it goes out and watch what happens. It opens IE for me. So if you look at that code, now that's looking for a specific ID. But anyway, so you kind of see how that works. So those functions are not available until you run that function, and then once that function is in your shell, you can use that in your code to write programs or modules or whatever you need to run. So hopefully that clears that up between the modules and the programs and subprograms and functions, and again that should help you towards your final project. Let me know if you have any questions about that. So let's get back to the information this week. Okay, so this week we're talking about arrays, which are effectively a series of memory locations that store data with a single label or variable name. So we're going to talk about one-dimensional arrays, parallel arrays, character strings, which we're not going to spend too much time on that. Effectively, when you declare a variable as a string, it's setting up an array an array of characters. So we're not going to spend too much time on that, but we are going to spend some time on the two-dimensional arrays. It's going to be very important that you understand that. In addition to the parallel arrays as you work on your final project. So the array structure, and again, like I said, the array is a series of memory locations that store data, and those memory locations must be of the same data type. You can't mix those up. At least in this syntax. So there are some ways of doing that in certain programming languages, but that's beyond the scope. Each value in that array is stored in an element of the array, and those elements or those values can be accessed by index numbers or subscripts, and we'll get into that in just a moment. But it's very important to understand that the very first element in that array is element 0 or index 0. So let's take a look at example 6.1 on page 287 of your text, if you wouldn't mind turning to that page with me. Okay, so we declare an array variable as with the variable name scores, and you'll notice that we have a 25 in there. Now that 25 identifies the number of elements that are going to be in that array, and we declare count as an integer. So we can increment through this for loop and enter scores into every element of that array. Now notice what happens here. Now count equals 0. So the first score being entered is going to go into element 0. Now, as it counts up, it's going to count to number 24, and it's going to enter that score in element or index 24. And then when it increments to 25, it's not going to go through that loop again because it's looking for a count to be less than 25. Therefore, you'll notice that those elements go through 0. It starts at 0 and goes through 24. It's still 25 elements, but it only counts up to 24. So it's very important that you understand that as you're creating your for loops, because if you created a for loop that was testing less than equal to, you're going to count one more element than you have in your array, and your code's going to error out on you. So arrays, of course, must be declared like any other variable that you use in your code. Um, and again, like I said, the arrays, each element in those arrays are stored sequentially in memory. So let's take a look at example 6.2 for a little bit more advanced information on that. Okay, so this code sort of demonstrates the ability to enter data into your array and then extract that data back from the array once the array has been completely filled. So we declare a variable array called rain, and we declare that as a data type float. And again, every element in that array must be of the same data type. Um, we declare sum as a float and average as a float, and then our count variable is going to be an integer. Now you'll notice that my count variable is different from what they have in the book. I just don't like single letter variables, so please don't use that in your code. So as we count through, now the count variable equals 0. So of course the first iteration through this for loop is going to enter the rainfall for uh, for the month into the element 0. Now notice what happens. This output, when it writes this information out to the user, it says, okay, enter rainfall for month, and at this point, count contains a value of 0. So we add 1 to it to say enter the rainfall for the month 1 or January. But now notice also that does not change the value of that variable count. It just displays one number higher than what that variable is. So we iterate through this 12 times, and the user enters that data in for each month. So then it sets the value of our variable average to the sum of the 12 months divided by 12. And I think I missed a step in here. Let's do set sum equal to sum plus rain with an index of count. So we'll save that. And again, we set average to sum, which has been the addition of all 12 of those values contained in our array divided by 12. So we enter another for loop, and you'll notice that the variable count is being set back to 0 and counts up to 11, which is actually 12 our 12 elements or 12 indexes in our array. So it's going to print out the rainfall for month 1 is it gives you the contents of that element. So let's take a look at that real quick and see how that's going to look in memory. Now these values over here are simply the index number. This is not it's not a um, the contents of a memory location. This is just identifying where that memory location is. So, and then these are the potential contents of those memory locations. It's very important that you understand how that works, how index 0 is going to access the first index in that array all the way down to index 11 or element 11 is going to access that last portion of that variable array. So now, as the text mentions, there are several advantages to using arrays, and they're really cool. Now, different programming languages have different tools that are the same as or similar to arrays. PowerShell, for instance, uses hashes that are kind of the same as arrays, but used a little bit differently. But you can do some really cool stuff with that type of code. And it also, more importantly, it makes your code more efficient, or has the potential to do that, because you can store a pretty significant amount of information in an array or a multi-dimensional array, and then access that information again later on from another portion in your code. So it really does some pretty cool stuff, and you can generate some very elaborate code with using those arrays. Now, again, it takes a little while to wrap your brain on how that works, but it's very useful. Now, and later on in the chapter, again, we're not going to spend a whole lot of time on the string arrays that the text talks about, but just be aware that a string array is effectively um, an array of character data types, and each character in that array is a single element or a single index in that string array. So there are what are called parallel arrays, which are effectively they're still um, one-dimensional arrays that are used side by side that contain the same or related information. So let's take a look at example 6.3 on page 293, and then we'll see if we can see if we can take a look at how that works. Okay, so you'll notice that this code declares two variable arrays, one called names, and that's identified as a data type string, and then sales, which is declared as a data type float. And you'll notice that both of these have a variable size of 100, which means that it has 100 elements in both arrays. So um, we'll go down here, and now I've told you guys before, I'm not very fond of while loops to enter this type of data. That I think it could be done just as easily in a for loop, and usually a lot easier to read and to put in a flow chart. But in any event, you'll see that the variables max and count are set to 0, and you'll notice also that I used an actual variable name rather than a letter. Those are set to 0, so when you have the user enter the first set of values, it goes um, into the first element of that array. So this count right now, of course, is 0, and then as it goes through the while loop, it has the user enter that information, and it goes into each element of both arrays. So in other words, the user will enter the name of the user, of the salesperson rather, and that goes into index 0 of the array names, and then they enter the sales amount for that salesperson. It goes into index 0 of the um, sales array. So then it goes into the while loop, and It tests for the name's um, value that has just been entered by the user, and as long as it doesn't enter an asterisk, it will enter the loop. So and then it checks for the sales count being greater than max, and so on and so forth. So then it has the user enter the salesperson's name again. Um, I'm sorry. Let's back up one time. So it increments the value of, this should be count rather than k. Let's do count. Count. Sorry about that. In increments count one time. So now we're looking at index 1 rather than 0. So the user enters the next salesperson's name into the names array in index 1, and then it enters the salesperson monthly sales into the sales array and index 1 rather than 0. So it keeps doing that until, and it'll go on forever until that user enters an asterisk in the place of the salesperson's name. So hopefully that makes sense. And again, that's just parallel arrays, which effectively those are two arrays such as this that are side by side. And again, this information is going to be very useful when you start working on your final project, because there's an instance where you're gonna need to use that both to enter the data and then to display the data back out. All right, so let's take a look at two-dimensional arrays. Um, and again, these arrays are um, if if the array is declared as a certain data type, every element in that array has to be the same data type. Um, so when we were entering data into a one-dimensional array, it was pretty easy. We had a single index number, and index number 0 was the first element in that array, and then index 1, and then 2, and then 3, all the way down to the end of that array. Now, accessing the elements in a two-dimensional array is a little different because you need two index numbers, and I'll show you how that works here in just a sec. So the multi-dimensional arrays, this is what we discussed earlier, what I alluded to earlier as a table, and now an array, a multi-dimensional array can certainly be more than two dimensions, but we're not going to get into that because that gets really complex and it's hard to wrap the brain around. Um, but it's important to understand or to picture in your brain that as we declare these two-dimensional arrays, it's very important to understand that the first number is sort of signifies rows, and then the second number signifies columns. So let's take a look at example 6.18 on 328 to see how that works. Okay, so we are declaring a single two-dimensional array called scores, and you'll notice that it has a 30 and a 5, indicating that there are 30 indexes or 30 elements in one direction and 5 elements in another direction. So, and again, this is this can be pictured as the rows. The first number can be pictured as rows, and then the second number pictured as columns. So let's take a look at how that works. We also declare a student as an integer and test as an integer. And we have a nested for loop here, and you'll notice that the student is set to 0 because we're going to be accessing the first element of that array, of that the first dimension of that array, and then test is also set to 0, so because the second dimension of that array is also going to be has to start at 0. The first element is always 0. So as student is equal to 0, it will output to the user enter 5 test scores for student number. And now again, we don't want to enter or display out to the user student number 0, so we have to increment this by 1. Now we can use student plus plus, or we can use student plus 1. It's all the same. So once we get into once we display that out to the user, then we enter the second for loop, and we have test equals 0. So you'll notice that student equals 0 and test equals 0. Now student, of course, is the number of columns. That's going to be, if you look at page 327, figure 6.7, that kind of shows you how that information is stored in memory. So student number 1, which is actually student number 0, or element 0, is so that's our first iteration through this outer loop, and then the inner loop has 5 iterations where you enter the test scores. You'll notice also in that figure that it has 5 values going into the 5 different elements in that array. So once that inner loop has incremented or has gone through 5 iterations, you'll notice that test will equal to 4 for that last test score, and then when it increments to 5, it's no longer less than or equal to, I'm sorry, it's no longer less than 5. So it exits that for loop, goes back to the top of the outer loop, and increments student by 1. So now we're entering the 5 test scores for student number 2, which is going into element 1, or row 1 of that the first dimension of that array. So again, this is pretty. It's pretty important that you understand that and wrap your brain around that. If what I've done has confused you even further, please let me know, and I'll try and clear that up for you. So now you can also use the for loop, similar to what we just used to enter that data, and to it just basically display that data back out. So let's take a look at that, and we'll use the same example, but I'm going to modify that just a little bit. So let me see if I can work that out for you. Okay, so we've already gone through this first segment of code and entered all the test scores for all 30 students. So once we leave this nested loop, it will come down here to the second nested loop, and notice it effectively does the same thing, and sets student to 0 and test to 0, which those values are accessing the elements in our two-dimensional array. So when that element is 0, 0, it's going to print the scores for student number. Of course, it's going to print student plus 1, and it's going to print the contents of 0, 0. Don't need a space right there. And then tab, and then when when test increments by 1, it's going to print the contents of scores 0, 1, and then 0, 2, and then 0, 3, 0, 4, and 0, 5. And once that is complete, I'm sorry, it will count 0, 0, 0, 1, 0, 2, 0, 3, and 0, 4, but it never reaches 5 because 0 through 4 are the 5 elements that we wanted to access, right? So once that happens, it goes back to the top of the outer loop and sets student to 1 and does after it prints our new line here, it prints the same information for student number 2, student number 3, all the way down to student number 30. So let's take a look at how that data looks in memory. So again, if you go to page 6.7 in your text, it shows you exactly how that data is going to be stored in memory. So where you have student 1 and test 1, that's actually the index is 0, 0. So right here, that's going to be scores 0, 0. And then 0, 1 is going to be still student 1 and test 2, or at that point test is going to equal 1. So hopefully that makes sense. Hopefully I haven't confused you even further. But again, it's very important that you understand that information. Um, if you have any questions at all, let me know, and I'll be sure to clear that up for you. All right, good luck on your final project, and we'll talk to you next Saturday.